These are the notes for section 5.4 on the sum and difference formulas. Now the sum and difference formulas you're going to need to memorize, and they're in your notes, and so we'll be using them. And basically they are that the sign of A, whether we're adding or subtracting B, equals the sine of A, the sine of the first angle, times the cosine of the second angle, plus or minus the pluses. Notice the plus is on top. The addition inside the parentheses is on top. So we're going to add them. And then it's the cosine of the first angle, sine of the second angle. Oh, that's a bad one. That's the sine of sum and difference. Now let's look at cosine. Cosine looks very similar. However, we're still doing A and B, but this time it's cosine A, cosine B, and our signs are going to switch. It's going to be minus over plus. So if we're adding with cosine, we're actually going to end up subtracting in our formula. If we're subtracting our angles, then we're actually, in our formula, we're going to use the addition. Times the sine of A, sine of B. So that's for sine and cosine. Now we have tangent. Tangent of A plus B can be done two ways. It could be the sine of our angle over the cosine of our sum and difference. Or we could use this. Tangent of A plus or minus tangent of B over 1 minus plus, notice the sign switch directions, tangent A times tangent B. Now when you come to class, you're probably thinking, we're going to teach you a way of how to memorize these a little faster, and it'll help you. But you do need to memorize these. So here's how we're going to do it. So let's look at our first example. Example 1 says I want the cosine of 7 pi over 12. To find the cosine of 7 pi over 12, I'm going to use my denominator of 12, and I'm going to find two angles that add to be 7. Now the key thing about these two angles is that they have to also be on our unit circle. So my denominators are going to be 12, and I need to know whether it's going to be add or subtract. And it doesn't matter. They have to come out to be a 7. And I know that numbers that add to be 7 are 1 and 6. Well, 1 over 12, not on my unit circle. Or 2 and 5. Well, 2 over 12 is on my unit circle, but is 5 over 12? No, because I can't reduce that fraction. And then 3 and 4. Well, 3 pi over 12, that just reduces to be pi over 4. That's on my unit circle. And if I add 4 pi over 12, that's also on my unit circle. So those are the two I want to use. And now I'm just going to reduce them. And I get the cosine of pi over 4 plus pi over 3. Now, pi over 4 here, this is my A. Pi over 3, this is my B in my formula. So every place I see A, I'm going to put pi over 4. Every place I see B, I'm going to put pi over 3. And so the cosine, it's going to be the cosine of A times the cosine of B. Now, since we're adding these here, remember cosine changes to minus. The sine of A sine of B. Okay? Now we just have to simplify it. So again, what I've done is I first found two equivalent fractions that added to be 7 pi over 12. I have to make sure that when reduced that they're on my unit circle. Once I have those, then I just apply them to my formula. The first angle goes into A, the second angle goes in place of B. Now I just simplify. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. Minus sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. Simplify our fractions, and I get root 2 over 4 minus square root of 2 times square root of 3 is the square root of 6 over 4. Everything's over 4, so I'm going to simplify a little bit more, and that's going to be root 2 minus root 6 all over 4. And that's our final answer. Okay? So that's example 1. Example 2 is going to be very similar. So let's go on to example 2. This time I am doing sine. Oops, I hit the wrong button again. I'm sorry about that, guys. Sine, so here's example 2, of negative 5 pi over 12. Okay, so I need to figure out what two angles are going to give me a negative 5 pi over 12. Well, I could do, let's see, I want this 12. And you can use any angles as long as it gives you a negative. Hold on, I don't want this negative here because I don't know if I need a negative there. All right, so I need a negative 5. So I could do, so 1 minus 6, that would give me a negative 5, but 1 over 12 isn't on my unit circle. 2 minus 7, but that's not on my unit circle. 3 minus 8. 3 minus 8 is on my unit circle. So I'm going to use 3 minus 8. Now that's going to simplify because we want to reduce our fractions, and that's the sine. Well, 3 pi over 12 is just pi over 4, minus 8 pi over 12 is 2 pi over 3. Now let's apply our formula. Sine is sine of A, cosine of B, minus cosine of A, sine of B. Well, the sine of A, so sine of pi over 4 is root 2 over 2. The cosine of 2 pi over 3, well, cosine of 2 pi over 3 is negative 1/2. So I'm going to put negative 1/2 here. Minus cosine of pi over 4 is root 2 over 2. Sine of 2 pi over 3 is root 3 over 2. Simplify, I get negative root 2 over 4 minus root 6 over 4 And that gives me just negative root 2 minus root 6 all over 4. Okay, so that's example 3. Let's go on, or example 2, I'm sorry. Let's go to example 3. I want the sine of 11 pi over 12. Again, we have to do the same thing. We have to find two angles that add or subtract to be 11 pi over 12. And they don't have to be less than 12, so we could use things like 14 pi over 12 minus 3 pi over 12. We could do that. Hey, let's use that one. Okay, well 14 pi over 12 is just 7 pi over 6. Minus pi over 4. All right. So now let's use our formula. So I am subtracting this time, so it's the sine of the first angle. So the sine of 7 pi over 6. Cosine of the second angle. Minus cosine of the first angle. Oh, that's not a 6. Sine of the second angle. Well, the sine of, and I can put parentheses around these, don't have to, but you can. Well, the sine is 7 pi over 6, that's in the third quadrant, and that would be negative 1/2. Cosine of pi over 4 is root 2 over 2, minus cosine of 7 pi over 6 is negative root 3 over 2. Sine of pi over 4 is root 2 over 2. Simplify it, and I get negative root 2 over 4. Now I have a negative times a negative, that's going to make that a positive, so plus root 6 over 4. And you could leave it as negative root 2 plus 6, but it kind of looks cleaner if you put the positive in front. So we end up with negative root 6 minus root 2, or excuse me, we end up with root 6 minus root 2 all over 4. So these are not really difficult. It's going to be finding those two angles that are going to combine to give you the one that you need. So you're going to have to get a little used to your fractions. All right, so that's example 3. Let's go to example 4. Example 4 is our first one with tangent. And so I want the tangent of pi over 12. Why am I putting 4? Okay, I need a 12 there. Well, tangent of pi over 12, so I need to get a 1. So like 4 minus 3. Well, I know 4 pi over 12 is on my unit circle, minus 3 pi over 12. Oh, I hit it again, I'm sorry. Got a tiny little screen to write this on. Now, my formula for tangent. Because I haven't found sine and cosine for these angles, I need to use the one that has tangent in it. So it's so this is going to actually be the tangent. Let me reduce these fractions before I go any further. 4 pi over 12 is pi over 3 minus pi over 4. Formula for tangent is the tangent of the first angle, so tangent of pi over 3 minus the tangent of pi over 4 all over 1 plus the tangent of pi over 3 tangent of pi over 4. Well, the tangent of pi over 3 is root 3. Tangent of pi over 4 is 1. On the bottom, I'm going to have 1 plus root 3 times 1. So that's going to give me root 3 minus 1 over 1 plus root 3. Well, we need to rationalize our denominator because we can't leave that square root down there. So we need to multiply by the conjugate of our denominator, and that's going to be 1 minus the root 3. And so when I do multiply by my conjugates, on top I'm going to get the square root of 3 minus 3 minus 1 plus the square root of 3 over 1 minus 3. So that's going to give me negative 4 plus 2 square root of 3 all over negative 2, and that's just going to simplify to be 2 minus the square root of 3. Okay? And that's our tangent. That's number 5, or number 4. Let's move on to example 5. Okay, so the next 3 examples are all going to be just a little bit different than what we've been doing. And so what we are going to be giving, just using some algebraic expressions. The first one is the sine. I want the sine of u plus v. I know that I'm given sine of u is equal to 4/5, and it's between 0 and pi over 2, so it's in quadrant 1. Okay, so this is important. It's in quadrant 1. Cosine of v is negative 12 over 13, and this one is in between pi over 2 and pi, so that's in quadrant 2. So what I'm going to do is I'm actually going to make some triangles here. So I'm going to make the first triangle for u, and that's in quadrant 1. Well, sine, remember, is opposite over hypotenuse, so that means that this is 4 and this is 5, and using our Pythagorean theorem, it means this opposite side is 3. So we need to do this part first. We need to use our make our triangles. Well, for cosine of v, it's in quadrant 2, where this is negative 12, and this is 13. Again, using our Pythagorean theorem, 13 squared minus negative 12 squared gives me 25, and the square root of 25 is 5, so this opposite side is 5. Now, using our 2 triangles here, again, this is v, and this is u. I'm going to apply my formula. So the sine of u plus v equals the sine of u cosine of v plus the cosine of u, the sine of v. And looking at our triangles, the sine of u is 4/5. So I'm going to put a 4/5 here. So you have to keep your triangles separated. You have to know which one is u and which one is v, because you're going to use them as your reference points. Cosine of v is negative 12/13 plus the cosine of u is 3/5. The sine of v is 5/13. Now we just do some basic arithmetic. 4 times negative 12 is negative 48. 5 times 13 is 65. Plus 3 times 5 is 15 over 65. Combine those and I get negative 33 over 65. So the sine of u plus v is equal to the negative 33 over 65. Okay, so that's example 5. Let's look at example 6. It's the same idea as 5, but this time we're going to do cosine. So this is 6. And I know that I want the cosine of u minus v given that the sine of u equals 1/2 and it's between pi over 2 and pi. So it's in the second quadrant. And that the cosine of v equals negative root 3 over 2. And it's between pi and 3 pi over 2. Alright, so let's set it up the same way. So sine of u. Now you should notice that these numbers are like 1 over 2 and root 3 over 2. They seem kind of familiar. So sine is 1 over 2. And then that would make this root 3. And again, this is in the second quadrant, so that makes that a negative root 3. So we can be careful with our cosine. Our cosine of v is in the third quadrant, where this is negative root 3. Let me rewrite my triangle here. Over 2. Well, that would leave this side as 1. Now let's apply our properties. So I'm doing the cosine of u minus v. So my formula says I need to take the cosine of first angle times the cosine of the second angle. Because I am subtracting them, I'm actually going to end up adding sine of the first angle, sine of the second angle. Cosine of u, well, it helps if I mark my triangles. So hold on a second here. This is u, and this one's v. So the cosine of u is negative root 3 over 2. Cosine of v is also negative root 3 over 2. Sine of u is 1/2. Sine of v is actually negative 1/2. I forgot to write the negative sign on the, because I am down here in this third quadrant. That should be a negative there, so let's simplify. Square root of 3 times square root of 3 is just 3 over 4. 1 times 1 is 1 over 2 times 2 is 4. And I get 2 over 4, which is equal to 1/2. And there's my final answer. Okay, so that's example 6. Let's move on to example 7. Okay, we're going to rewrite. Example 7 has us rewrite it as an algebraic expression, and I have that I want to rewrite the cosine of arctan of 5x over 7 minus the arcsine of 8 over x plus 2. Okay, and you're probably looking at this like, oh my gosh, what all am I going to be doing? Well, it's kind of like just like the ones we just did. This arctan here, we're going to pretend this is u. Arcsine is going to be our v. We're going to make two triangles. Same thing. Now we didn't give you quadrants, so just put them in the first quadrant. That is a horrible, horrible straight line. That's better. Okay, tangent is opposite over adjacent, so this is 5x over 7, and that's going to make my hypotenuse. Then 25x squared plus 49, and it's the square root of all of that. And we've been doing these for a little while. Again, using Pythagorean theorem, that's what I'm going to get 5x quantity squared plus 7 squared. Now let's do v. Same thing. This is v. Sign is opposite, so that's 8 over x plus 2. So the adjacent side is now going to be the quantity x plus 2 squared minus 64. Now we have everything we need to do our formula. So for the cosine, I want the difference formula for cosine. That is the cosine of u times the cosine of v minus, or excuse me, we're minus, so this should be plus, the sine of u, sine of v. Well, looking at my triangle, the cosine of u is 7 over the square root of 25x squared plus 49. And this is going to be times the cosine of v, which is the square root of x plus 2 squared minus 64 over x plus 2. Okay, now let's do the other side. Plus the sine of the first one, and that's 5x over the square root of 25x squared plus 49 times the sine of the second one, which is 8 over x plus 2. So to simplify this, notice that the denominators of both fractions are the same. Oops, that's what I want to do. Trying to move things here. So we can put everything over one denominator, and it's the square root of 25x squared plus 49 times x plus 2. In my numerator, I have 7 times the square root, and I'm writing this really big, and I don't understand why. Let me adjust this. 7 times the square root of x plus 2 squared minus 64 plus 5x times 8, which is 40x. Now, we're not going to make you do any more with it. Just leave it like this. This is an algebraic expression, and we're now done. Okay, so these are the notes for sum of difference formulas. Make sure you have any questions. If you have any questions, come to class with them, and we will talk to you then.